Hello everyone, how you all? So today I'll be discussing about a very beautiful concept, that's electrostatics. In nature, we come across different charges, that's positive, the few are negative, but most importantly, let's start with the fundamental, that's atoms. Almost everything is made up of atoms. But what charge an atom possess? That's electrically neutral. Why so? Because it is comprised of a combination of positively charged protons and equal number of electrons, right? So which make the atom electrically neutral. So whenever we talk about charges, there exists one more thing which comes along with it, that's forces. Yes, as we all know, we have different types of forces in nature. That's gravitational force which act between different masses, and we have electromagnetic forces which is having its subpart as electrostatics. That's what we will be discussing today in little more detail. Now let's focus on this electromagnetic forces. So it is made up of two parts, electro and magnetic. So in today's class we'll be discussing about this electro part, which is electrostatics, and magnetic basically deals with magnetism. Now electrostatics. Statics mean charges at rest, right? Dynamic means something is moving. So this statics means charges are at rest. So as I said, whenever these charges are there in our mind, whether positive or negative, there is some kind of force between them. So if you have like charges, suppose you have a positive charge and in front of it there is another positive charge, or maybe there's a negative charge and in front of it there's another negative charge, you can see that there will be a force of repulsion between them. Yes, right. So they will try to push each other apart, right? Now when we talk about unlike charges, that's a positive charge in vicinity of a negative charge, so that's where we have force of attraction. We know that there will be force of either attraction or repulsion, but what value will this force possess? How strong this force will be? So this is being discussed with the help of Coulomb's law of attraction. So which states that if we have any charges, suppose positive, let's take Q1. We don't know whether it's positive or not. Let's take this as Q1, the other one as Q2. And if they are being separated by a distance r, suppose, so they will be experiencing a force having a value k times q1 q2 over r square, which means if the charges are strong, forces will be strong. That's directly proportional to the charges, more specifically the product of charges. Also, if you have the distance quite closer to each other, if you bring those charges quite closer to each other, they will apply a stronger force. So if the distance is less, so the force will be higher, that too at a magnitude of a square. Suppose you have a positive charge and a negative charge which is quite close to each other, and they are almost touch to each other, they being trying to attract each other. If you are trying to pull them apart, you will need a tremendous amount of force. The reason being they are quite closer to each other, right? Now when you talk about charges, if you double one charge, suppose Q1, then the force will also be doubled. If you double another charge, that's Q2, again the force will get doubled. But if you double them both together, the force will be 4 times. 2 times this, 2 times this, the force will be 4 times. So that's what we have, the force of Coulomb, that's k q1 q2 upon r square. Now this k depends upon medium. K over here depends upon medium. Usually we write this as 1 over 4 pi epsilon. epsilon over here is basically permittivity. The name itself suggests that it will permit. Suppose it actually depends upon medium. If you are putting these two charges in water, they will behave differently. The force of attraction might be different as compared to when you put these two charges maybe in mercury or maybe some other liquid, alcohol maybe. So it depends upon the medium. This K value depends upon the medium, and this K itself depends upon epsilon. The name itself is permittivity, which tells you how favorable the medium will be for the charges to get attracted or repelled, right? But when we talk about permittivity in free space, which is vacuum, there is no molecules or atoms, anything in between, that's called as epsilon naught. Now this is called as permittivity in free space. This will have its value as 8.85 times 10 to the power minus. Now when we put this value epsilon, the K value becomes 9 times 10 to the power 9. To find the unit, it's very simple. You get this K over here, force is Newton, R square is meter square over there, Coulomb square getting divided, so Newton meter square over Coulomb square. And this epsilon naught will be having the unit as the reciprocal of it. That's quite easy, you can find it out. So you have epsilon naught as permittivity of free space and K value, which basically we use for our calculation purpose. But now this will just tell you about the value or the strength of forces. If you are interested in finding the direction, yes, you can say that, oh, there is a repulsion, it will go out, there is an attraction, it will come inside. But what about in terms of mathematics? That's simple. We will apply principles of, yes, correct, vectors. Force being a vector quantity, it will be written as force equals K Q1 Q2, that is the magnitude, upon R square. But let's take Q1 over here the charge, Q2 over here the charge. Let's take both positive. Now this Q2 charge is at a distance R. In terms of vector, if I take Q1 as origin, this is what I can say that Q2 is at a position vector of R vector. Now this R vector will have some direction, so we take that as R cap, unit vector along the R vector position vector, that is R cap. But if we will say that, okay, Q2 charge will experience a force outwards in this situation because they both being positive, it will repel outwards, yes, correct. But outwards is also the direction of right R cap, right? R cap, that's unit vector. So I will simply say that this force F vector will have its direction similar to the position vector direction, that is R cap, right? Quite easy, great. Now we will do some modification. In terms of vector, we know that R vector equals R times R cap. So R cap will be R vector over R. I will substitute it over here. Now my force will become K Q1 Q2 over R square time R vector by R. See this, I have just plugged in R cap. Instead of that, I have substituted R vector over R. So my force over here equals K Q1 Q2 over R cube times R vector. This is in the form of vector, that is specifically position vector. So you can identify the force in terms of position. So you can also say, write over here as force of second charge with respect to first charge will be equal to K Q1 Q2 over R cube times R, position of second charge with respect to first charge, right? Similarly, you can get the vice versa. Force on the first charge will be with respect to second charge, that will be the same thing, but the position of the first charge with respect to second charge. So we will be using the principles of vector over here for solving and calculation purpose. But what about if we change charges? If I take a negative charge instead of this, yes, you are right, the direction of force will be inside, opposite to that of the position vector. So simply, instead of Substituting Q2, you are just plugging in a negative charge. So the negative sign involved over here will tell you the negative value, suppose any value A times r cap. The negative value, talking about the principle of a vector, this negative vector says that the force is opposite to the direction of a position vector. See, this one single formula can tell you about the strength of the force, the direction of the force as well. If you have both negative, suppose Q1 as negative, Q2 as negative, the value will be positive. So yes, right, both negative means they will be repelling. They will move away from each other. So the object will go away, and that's along the direction of the r vector. So the force will have the same direction as that of r vector. In the case if both are negative. If both are positive, again repulsion, that's the same thing. Plus into plus plus. But if any one of them is negative, suppose Q1 negative and Q2 is positive, the product will be negative. But the position vector direction is towards right, and the direction of the force will be opposite to it, negative. There is a negative sign. So opposite to position vector, that is inwards. That's attraction. So this will be similar for if suppose Q1 is positive and Q2 is negative. So these two charges will attract each other. The direction of force is opposite to that of direction of position vector. So that is r cap. So this is the beauty of representing forces in terms of the position vector, right? I hope you enjoyed the concept and got the clarity at the same time. Hoping to have more sessions like this. Thank you so much.